All right, I'm on a single screen today, so if I'm moving a little slower than usual, is because I have to do everything just on the one screen. All right, but we'll see how it goes. All right, so we have, I'm just going to bring up module 1 so that we can just go through the content of module 1 first before we jump into the section that I want to do. And right, so as it is right now, we have the concept of abstract data types. I'm not going to talk about abstract data types. Mainly module 1 in unit 2 it talks about abstract data types to manipulate data. It talks about searching and sorting in order to solve problems. You have done some measure of searching and some measure of sorting already. Okay, we would have covered something, not officially, but especially in terms of searching, you would have done a search already, okay, in unit 1, where we would have created our IA. Some people might have done a sort, but that was a little optional. I didn't really push on the sort for your SB for unit 1, but these are not concepts foreign to us, okay? So just to go through the concepts of this and then to tell you what we're going to focus on today, we have the concept of ADTs. We want to talk about ADTs themselves. What are ADTs? We have different types of ADTs that we will focus on. ADTs are abstract data types. We want to know how to add elements to abstract data types, remove elements from abstract data types, find elements in abstract data types. Okay, we're going to talk about the concept of primitive and non-primitive data types and linear and non-linear data structures. This is not the focus of today. We're just going through what is in the syllabus. And these are the different ADTs that we're going to look at: stacks, queues, circular queues, and linked lists. Okay, so we want to be able to, at least once we understand ADTs, and it's not a hard concept to understand, and the characteristics of ADTs, we want to be able to implement and manipulate these data types. So again, we then go on to talking about different characteristics of these ADTs, the way in which they're implemented, different functions associated with them for like stacks and queues, etc. And for linked list as well, we have different functions associated with them, and we have to write programs. So this is, even though it's in the beginning, we're going to not start with this. We're actually going to start with the simpler concepts of searching and sorting algorithms using one-dimensional arrays in C. Okay, we'll do it in C, but we'll start off by just talking about the concepts behind them. And I think that we can maybe not, even if we don't implement all of them today, which is a kind of hard ask to implement all of them in one day, maybe we, as I said, we can go through the different searches today, and then we can go through the different sorts on at the next class. Everybody good with that?
Kind of, sir.
Yes, sir.
Right. So cool. So let me open my board. All right. So we have we're going to talk about searching. Okay, searching as a concept, and what we start off with is that we have to start off with an array to be able to search some set of data that you want to be able to search. To search, as I said, and we'll start with linear searching. And the linear search is a nice, simple search. It's actually a, very, very basic search where you have the concept that that you search through every element in a data set until you find the value, or you finish the set of data, right? So let me just write it out. This search technique goes through every element in a list until it either finds a given search key or it reaches to the end of the list and there is no more to search. Okay, that's all there is to the linear search. Simple, right? Is Hazard back yet? I guess he's not. All right, so it goes through every element in a list until it either finds a given search key or it reaches to the end of the list and there is no more to search. So how do we implement this? We implement this by essentially having two things. We need to have two things for our linear search. In our linear search, we have to have a search key and we have to have a list. And there is no special ordering to this list, but because we're using one-dimensional arrays, it just has to mean that all of these lists have to have elements of the same data type. Okay, so we can use an integer list. And say, for instance, we have some values in our list 9, 2, 66, 1, 3, 17, 92, 84, 61, and 77. Okay? Just like every other list that we have, our list, of course, will have an index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And our search key is just an integer value that we will use to compare against every key value. Hold 1 second, please. Yeah, sorry about that. Right, so the integer, everybody hearing me, right? Yes. So let's say, for instance, our search key is 3. All right, our search key is 3. What is going to happen is that it's just simple. The value 3 will be compared against every other value in this list. So we could take a look at 3 compared against 9. It's not a match. It's not a match. It's not a match. It's not a match. It matches. And then what happens is typically you return the location. So you say key was found at location 4. Simple, right? Some of you all might be wondering, sir, why are you teaching me this very basic, very easy to understand concept with respect to programming? Listen, this is what we have to know. This is where we're starting off. Anybody doesn't understand the concept of linear searching so far? Yes, no?
So if you understand, sir.
All right, thank you. That's all I'm asking for, just a little feedback, Very straightforward, right? So then, what is my ask then? Because if it is very straightforward, then I'm going to ask us to implement it right now on our own in C or as an algorithm. Okay, so I'm going to give you all 15 minutes. It's 20 past 9. I'm going to give you all 15 minutes. And then when we come back, I'll ask a couple of you to share, and then we will discuss the solution or the algorithm for a linear search. Now, I'm going to write down the requirements for what we have to do, right? So we are going to write a C program that allows a user to enter a key value and a range of values, right? Range must be greater than 20. All right, so the range must be greater than 20, which will populate an array of size 10 with values from the range. Okay? So you're asking a user to enter a key value and they're entering a value within the range. The range must be greater than 20 and it will populate an array of size 10 with random values from the range. Program should search a list of random values within the range and return the locations of all of the elements in the array which match the key value. If no value matches, then the program states that the key value was not found. Any questions? Anybody does not understand this assignment?
Sir, I understand the assignment and it's I don't know.
You can do it in pseudocode if you want.
Okay, thank you.
All right, so you can do it in either pseudocode or you can do it on your compiler. So you have 20 minutes. I'll give you 20 minutes instead. I'll bring up the timer. And we are off. So I'm going to stop recording now, and then we will splice we will start back, sorry, the recording when we're going through the solution.